Okay, this is an exercise from section 8.1, Basics of Hypothesis Testing. This is question number 4, or you can refer to it as 8.1.14. Now, in this example, they have given us the test statistic of z equals 0.68, and that was obtained when they were testing some claim that the proportion of a population was greater than 80% or greater than 0.8. Now in part A, we have to identify the hypothesis test as being two-tailed, left-tailed, or right-tailed. In part B, we need to find the p-value. And then in part C, we're going to use a significance level of alpha being equal to 0.01. And then we need to determine, are we going to reject our null hypothesis or are we going to fail to reject our null hypothesis? So I have set up a little bit of some scratch work here to try to get at the root of this. So this, in part A, we're to determine if it's a two-tailed test, a left-tailed test, or a right-tailed test. Well, for that we need the claim. And it really helps if your claim is in the symbolic form. So our claim is that the proportion is greater than 0.80. Now notice that the inequality symbol is a greater than symbol, but notice that the apex of the greater than symbol is pointing to the right. So that tells you this is a right-tailed test. So that's how we can answer part A. This is a right-tailed test. If it were a less than symbol, then that would be a left-tailed test. And then finally, if it were the not equals sign, that would be a two-tailed test. But in this case, these two are not applicable. We do have a greater than symbol, so this is a right-tailed test. Now, in part B, the way we're going to find our p-value, the p-value is the area to the right of the test statistic. And it's to the right of the test statistic in this case because this is a right-tailed test. So if you think about our sort of our normal distribution and what it looks like here, right? Since this is a right-tailed test, I have the test statistic somewhere on the axis, and the area to the right is going to be my p-value. So I'm going to need my normal calculator for that. Now, fortunately, they've told us that our test statistic is 0.68. So this is definitely not to scale, but if I find the area to the right of 0.68, then I will know what my p-value is. So let's go look at that. So let's answer the first question. We know that this is now a right-tailed test, so we should get that one correct, and we do. Now let's find the p-value. So remember that for our p-value, our test statistic is 0.68, and it's listed right here, 0.68. So I'm going to go Stat, Calculators, and since this is a z-score, I'm going to open my normal calculator. I'm going to leave my mean and my standard deviation for the standard normal distribution. I'm going to change my inequality to be greater than or equal to, and then I'm going to look up 0.68. And when I hit compute, this picture should match what it is I'm looking for. Right? This red is the area to the right of 0.68. And so that tells me that, now they want 3 decimal places, so that tells me that my p-value is going to be 0.248. So I should be able to key that in, 0.248, check that answer, and we get that one right. So that's how we determine what tailed test it is. That's how we determine what our p-value is. And now, are we going to reject or fail to reject our null hypothesis? Well, that has to do with alpha. So notice that they've given us an alpha of 0.01. Now 0.01 is less than 0.248. So let's write this out. So 0.01, so our alpha is 0.01, and our p-value is equal to 0.248, so 0.248. And so we know that 0.01 is less than 0.248. So that means that our p-value is higher than our alpha. And we have a little, you're going to hear me say this a lot, but when the p-value is high, the null must fly. So since the p-value is greater than, since the p-value is greater than alpha, then we are going to fail to reject our null. Fail to reject our null hypothesis. So I'm going to go back to our problem here. I'm going to select which one of these is the case. Now remember, we're failing to reject our null hypothesis, so there's a little bit more language here. We are failing to reject our null hypothesis. So we could use this chart. This is found in our textbook. So we start, does the original claim contain the condition of equality? And it does not, so no. Do we reject our null hypothesis? No. So we're going to say that there is not sufficient evidence to support the claim. So we fail to reject, and there is not sufficient evidence to support the claim. So this flow chart can help immensely when you're trying to figure out these multiple choice portions. So I'm going to go back here. We fail to reject. There is not sufficient evidence to support our claim, and I check the answer, and I get that one right. So that is how you can work on finding the p-value, determining the tailed test, and then using the significance level and the p-value to determine if you're going to reject or fail to reject your null hypothesis.